Hello and welcome to the section 2.8 lecture today. So the reason I put that in quotations is your book doesn't technically have a section 2.8. We are using this to we're kind of adding this to our book a little bit. There's some things that we covered in the past that you covered years prior. And your book assumes that you covered it once, you must be great at it. I would rather not make that assumption and make sure that we could actually do some problems, even though they were something that we covered previously. Trying to address the other elephant in the room, you're going to have to ignore this Smart Notebook watermark. There's no way for me to get rid of that right now. But I'll try to get rid of it in the future, and I'll try to make sure that anything I'm doing that's important won't be in that same spot. Okay, so today we're looking at adding and subtracting fractions that have common denominators. When we add and subtract fractions, we want to add the tops and leave the denominator the same. Okay. So I should say when we add or subtract, we want to add or subtract the numerators, the numbers up top, and then leave the bottom the same. So if I look at 3/10 and 4/10, one nice intermediate step is to bring those numerators together and add the 3 and the 4 in the top, and then come up with our solution there. 3 plus 4 would be 7, and to say that that's 7/10. Number line wise, I think it's a good visual to think about, to start at 3/10 and then count your way up 1, 2, 3, 4/10 and see where you land. Okay, I don't think that these models that I have and these kind of diagrams for the problems do a very good job if you just think about them being completed. I think it's better to think about that, like think about a visual of that actually happening, and then that's what makes it the most helpful. Okay. And then, I guess they want down here, 3/10 plus 4/10 is 7/10. The next example that I have here is 5/4 plus 3/4. These would be called unit fractions, where we think about one, whatever the denominator is, repeated over and over again. Technically, you could just kind of keep this going and say that's another 1/4, and then just add the rest of them that way. I don't think it would be a terrible idea. And just count up how many you have. Again, that's kind of more on the visual side right there of how you could think about the problem. Again, I do prefer kind of the more math approach because it takes up a little less room. And if we don't need that, I wouldn't want you to think that you have to display your answers this way. But I do think it's a really good way to process the problem and to think about it. So if that's something you want to do, you can. I'm more of a fan of knowing what the math behind it is, that if I have 5/4 and 3/4, even though 5/4 is a improper fraction, we can still do the problem just the same. Add 5 and 3, and get 8. Okay? And then 8/4 is probably better displayed as 2. So 5/4 plus 3/4 is 2. When we want to look at some examples down here, if you want to pause the video, you can, and then just check your work, see how you do. Otherwise, we're going to get these ones done. I have the 1/4 plus 2/4 giving me 3/4. I will say that intermediate step I really do like. I know that I think about this step almost all the time. I maybe don't write it every time once we get kind of past today. But 6 plus 2 is 8, and we have 8/5. I'm okay with that as my answer, even though it's an improper fraction. Also, if you wanted to say it was 1 3/5, that would be okay also. But again, totally up to you. kind of what you prefer. Number 3 brings up the idea that while we could reduce these ahead of time, sorry, my face is in the way. While we could reduce these ahead of time, I would never want to if it was going to mess up me having the same number on the bottom. Okay. In this one, I probably wouldn't. I see that I have 4 plus 4 over 8. Oh, that's good. 8. Which gives me 8 eighths. And 8 eighths is equal to 1. So again, don't mess up a good thing by trying to reduce early. We can always reduce later. The problems on the back deal with subtraction. So in subtracting fractions, we essentially do the same thing. We're going to subtract the numerators, leave the denominators the same. So 7 eighths minus 3 eighths is going to be 7 minus 3 eighths. 7 minus 3 is 4. And 4 eighths, we could probably do better than that. Feels like 1/2. Okay, so 4 eighths is 1/2. This would be kind of a tape diagram or a fraction bar. A decent idea to think about here is that I have 7 out of the 8 eighths, and I'm taking 3 of those away. Right, those are going away. Or maybe a better demonstration there a little bit. If I don't mess things up too bad. See how this works. I could like erase 3 of those. 1, 2, and 3. Right? So that's another option of what I could, like a mental process of the problems we're seeing. Okay. Either way, it's going to give me 1, 2, 3, 4 out of the 8. So 4 eighths, which is equivalent to 1/2. When we have whole numbers involved, that technically isn't a fraction. It technically doesn't have a common denominator right now, but we can make it have a common denominator. Okay. 1, if I want to write 1 in terms of fifths, it's always going to be 5 fifths. Okay. If it was 2, it would be 10 fifths. If it was 3, it'd be 15 fifths. Okay. We can always write that number in the denominator that I have. Okay. So 1 being 5 fifths, and we're going to subtract 3 fifths, gives us 2 fifths as an answer. This one kind of goes back to a number line idea. I really liked that one. Think about starting at 1, which is 5 fifths, and then moving backwards 3 and seeing where I end up. Right? I would end up at 2 fifths. Sounds perfect to me. Taking a look at these subtraction problems here. Make sure I don't cover up anything important. Again, I do like this intermediate step. I think it's a really good strategy to make sure that you know what is actually happening when we subtract or add fractions. 3 minus 1, though, would be 2. 2 halves is probably better answered as 1 whole. Number 2 brings in that whole number idea. I've got a 1 there. 1 would be 12 twelfths. And we're subtracting 8 twelfths. So again, I'd give myself my 12 minus 8 twelfths. See if I can move it down just a little bit. That would be 4 twelfths. 12 minus 8. And then we could probably do a little bit better. Those are both multiples of 4. Feels like a 1/3. And there we go. Number 3, kind of going back to the same idea from the last number 3, the adding number 3. I don't really want to mess up my common denominators right now. I can go 50 minus 30 on top and 100 on the bottom. 50 minus 30 is 20 over 100. That could simplify to 2 over 10, or probably better would be 1 over 5. You On both those third examples, you could reduce them early, and you could do that in a way that didn't mess up your sorry your what trying to do that. Sorry. You could do it in a way that didn't mess up your common denominators, but you just have to be careful. Looking at our last problem of the day, it is an application problem. It says that we have a pizza cut into 12 equal slices. I put equal in quotations because I feel like pizza slices are never quite equal. But then it says that John ate 5 slices for lunch. Later, Kim ate 3 slices as a snack. The question here is what portion of the entire pizza was eaten. I would say that the 5 slices would be represented as 5 out of 12. Kim ate 3 slices as a snack, so that would be a 3 out of 12. And what we're trying to do here is figure out how much of the entire pizza was eaten. So that feels like an addition problem. And it looks like 5 plus 3 would be 8 out of 12. Those are both multiples of 4. 8 is 2 times 4. 12 is 3 times 4. So I would say 2/3 of the pizza was eaten. There we go. Hopefully that helps make sense of what we're doing today. If you have any questions, please let me know. Otherwise, we will see you next time.